Hi, FOM 12 students. This is an answer key for the 6.1 homework. It was from page 383, numbers 1 to 4. And this is what it looks like. I may have to do some of the answers down below where I have more space, but I wanted to be able to see these graphs for number 1. It says, determine which graphs represent polynomial functions. Explain how you decided. Okay, so with polynomial functions, we looked at in the notes something called a constant function, which was a horizontal straight line. There are linear functions, sloped positively and negatively. We have quadratics, which is an up-facing parabola or down, and we also looked at cubic functions, which look like this or like this. And all of these functions are underneath this umbrella called polynomial functions. Okay, and so we have to look at our graphs here and see if they match up with the shapes that we have to the right. Okay, so A is not a polynomial function. Okay, because that continues to wave up and down, whereas we don't really have a wave over here. So A is no good. B looks like a quadratic. C looks like a cubic. D looks like a linear. E doesn't really look like any of those, and neither does F. So it's B, C, and D. Okay, and if you check the answers in the back of the book, I have a PDF of the answers of the back of the book on my website as well, and I think I sent it to you in the email this week. You see that the answers are B, C, and D for number 1. Okay, number 2, determine the following characteristics for each polynomial function in question 1. Okay, and it wants us to figure out the x-intercepts, the y-intercept, the end behavior, the domain, the range, and the number of turning points. Okay. Maybe we could do it like this. I am going to erase this. Okay, and we'll do it like this, guys. We'll say that this is number 2, and it wants us to determine the following characteristics: the x-intercepts, the y-intercept, end behavior, domain, and range, and also number of turning points. Okay, and we'll do all of this. We are going to do all of this for questions or for graphs B, C, and D. Okay, so with letter B here, the x-intercepts, we'll just look at them on the graph. It looks like -5 and -1. Okay, so you can see the x-intercepts right here and right here. The y-intercept is where it crosses the y-axis. That's right there at 2. Maybe I could write the word "and" properly. The end behavior, it goes from quadrant 2 here over to quadrant 1. So let's just say from quad 2 to quad 1. The domain for any quadratic is all real. The range is, let's see, -1, -2. The lowest y value is right here, and the graph goes up from there. So we should say y is greater than or equal to -2.5, it looks like. Looks like just a little bit lower. And the number of turning points, the graph comes down and then goes back up. So there is 1 turning point. Let's check the answers here for 2b. -5 and -1, 2, quad 2 to quad 1, all real. Y is greater than or equal to -2.5, and the number of turning points is 1. Good. Okay, for letter C, the x-intercepts are here at -2, -1, and +1. The y-intercept looks to be down there at -4. The end behavior seems to go from quad 3 to quad 1. The domain is all real because the graph goes from left to right forever, covers the whole x-axis, and it goes up and down forever, as you can see with the arrows, right? So all real for the range as well. Number of turning points, it comes up to this hill, so it goes up like this, turns back, so that's 1 turning point, and goes down and turns back. There are 2 turning points. Okay, I notice in the answer key we got the x-intercepts right. They're saying -5 for the y-intercept. Let's go check this y-intercept. Okay. It's kind of hard to see, but yeah, it's saying right, oh no, right here. -5 for the y-intercept, okay. Three to 1, all real, and 2. Everything else is right. Okay, part D, the x-intercepts. X-intercept right there. Boy, that looks like a fraction. 0.5 for that. The y-intercept is here at 2. The end behavior, you know how the quadrants go 1, 2, 3, and 4? It's going from quad 2 to quad 4. Domain is all real. Graph goes from left to right forever, and it goes up and down forever, so all real for the range as well. Number of turning points, does it stop and go back in the other direction? No, so 0. Okay, so the back of the book says 0.5 for the x-intercepts, 2 for the y-intercept, quad 2 to quad 4, all real, and 0. Okay, so things are looking good. Okay, number 3 says use technology to graph each polynomial function, determine the following characteristics for each function. Okay, x-intercepts, y-intercept, and behavior, domain, range, number of turning points. Okay, so let's do number 3 down here. Okay, and again, it wants us to do, it wants the number of x-intercepts this time. Number of x-intercepts. It wants the y-intercept. The end behavior. Domain, range, and number of turning points. Okay, and we're going to do this for A, B, C, D, E, and F. Okay, and it wants us to use technology to do this, so let's get out our graphing calculator, go to graph, and the first one is f of x equals 3x minus 1, so it's y equals 3x minus 1, and if we graph that, there we go. Maybe we could standardize the view window, and I'll go gsolve. Root are the x-intercepts, so 0.3 repeating, which is 1/3. Or actually, there's just one x-intercept because it wants the number of x-intercepts. So there's one x-intercept. It actually wants us to figure out the y-intercept, which is y ICPT. The y-intercept is at -1. You can see that the end behavior model goes, the end behavior goes from quadrant 3 to quadrant 1. So you know how it's 1, 2, 3, 4. So the end behavior is from 3 to 1. The graph goes from left to right, so it covers all real for the domain. It is all real for the range as well. So it goes up forever and down forever, covering the whole y-axis. And the number of turning points, because it's a straight line, there are 0 turning points. Okay, and if you check out the back of the book, it's consistent with that. Okay, let's delete that. Letter B is x squared plus 4. So I'm going to go x squared plus 4. Press execute, press draw. Okay. And we will press F5 for gsolve. Press root to get the number of x-intercepts. Not found. Okay, and you can see that the graph is not touching the x-axis, so there are 0 x-intercepts. Let's press F5 for gsolve. You press F4 for that y ICPT, y-intercept is up at 4. The end behavior, it goes from quad 2 to quad 1 as we move from left to right. The domain, the graph covers the whole x-axis that way and that way, so the domain is all real. Okay, but there... How high and low does the graph go for the range? It goes up forever, but its lowest point is at that y-intercept. So the range is y has to be greater than or equal to 4. We could put less than infinity for the other boundary. And the number of turning points, it comes down and turns back. So there is 1 turning point, and that is 3b. All right, let's check out letter C here. It is, we will go exit, let's delete that graph, and we're going to do this cubic, -2x to the power of 3 minus 5x plus 3, execute and draw. And I will go gsolve, find the root. There is 1 x-intercept. And let's go gsolve, and then F4 for the y-intercept. The y-intercept is 3. The graph, as we go from left to right, it's up here in quadrant 2. Remember how the quadrants go 1, 2, 3, 4? So it's going from 2 to 4. Graph goes from left to right forever with no breaks, so the domain is all real. Graph goes up forever and down forever, so the range is all real. And do we have any turning points? Does it come to a certain point and then turn back? It looks like there are no turning points. So that's 3C. Okay. Let's do letter D, which is 5x cubed. 5x to the power of 3. Execute. Draw. Okay, so it looks like there is one x-intercept. If I go g-solve and root, then it finds it for us. So there's one x-intercept. And let's go g-solve and F4 for y-intercept. The y-intercept is at 0. In behavior, it seems to go from quad 3 to quad 1. Graph goes left and right forever and up and down forever, so both domain and range are all real. And number of turning points. Does it actually turn anywhere? It sort of flattens out there, but then continues up. So 0 turning points. That was D. Exit. Delete that. Okay. Letter E is the constant function y equals -3. Okay, so y equals -3 is like that. If I try to find root, it's going to say not found. So you can see that there are 0 x-intercepts. G-solve and F4 for y-intercept. The y-intercept is at -3. The graph goes from quadrant 3 to quadrant 4. The domain, how far to the left and right does the graph go? All real. How far does the graph go up and down? It doesn't move up or down from that y equals -3 spot. So the range, the only y value that is used for that graph is -3. And it has 0 turning points because it's a straight line. Okay, and letter F is this graph, negative x plus 3 squared plus 2, execute and graph. Okay, so you can see there's 2 x-intercepts. If I were to go root, there's one there and there's one there. Okay, so there's 2 x-intercepts. The y-intercept is at -7. Graph seems to go from quadrant 3 to quadrant 4. The domain is all real because the graph goes from left to right forever. The range, the graph goes down forever, but it does have a highest point up here. If we were to go and find the max, the highest y value is 2, and then the graph is below that. So we would have to say that y is less than or equal to 2, greater than -infinity. It's the special way we say that. And number of turning points, it gets up to the top of that hill and turns back. So there's 1 turning point. All right, we are finally on to number 4. It says for each type of polynomial function below, sketch graphs to show all possible numbers of x-intercepts. And the first type is a linear function. And linear functions are either like this or like this, right? So really, you can either have one like that, which has 1 x-intercept, or you could possibly go down like this. Okay, so there's only 1 x-intercept. For linear functions. Okay, part B, for each type of polynomial function below, sketch graphs to show all possible numbers of x-intercepts and quadratic functions. look like that. So you could have 0 x-intercepts where it doesn't touch, or you could have the vertex right on the x-axis, which is 1 x-intercept, or you could have a quadratic like this where it has 2 x-intercepts. Okay, so those are the 3 possibilities for a quadratic function. It would be the same deal if it was this graph, if the graph was facing down. Okay, so 0 x-intercepts, 1 x-intercept, or 2 x-intercepts. And then finally part C, cubic. Cubic functions look like this, very roughly. So we could have a situation where it's a cubic like that, where it just has 1 x-intercept. Okay, or it could be like this, where it has 2 x-intercepts. Or it could be like this, right? 1, 2, 3 x-intercepts. All right, so there you go, everybody. That's an answer key for this week's homework. I will talk to you again soon.